Did you know that in a room of 57 people, there's a 99% chance that at least 2 of them share a birthday? I'll prove it to you. Hey everybody, it's Michael with Wasatch Math Tutors, and today we're talking about the birthday paradox, which isn't so much a paradox as it is a counterintuitive fact that follows from the laws of probability. First, let's rephrase the claim to one that's logically equivalent, but that will be a little bit easier to work with. In a room of 57 people, there is only a 1% chance that no 2 people share a birthday. Now, to prove that this claim is true, let's take our hypothetical crowd of 57 people, line them up, and have them one by one mark their birthday on a calendar. After they have each marked their birthday, we'll check the calendar and see if 2 people marked the same date. Our claim is that there is a 99% chance that this occurs, or equivalently, a 1% chance that no 2 people mark the same date. Now let's take a step back and recall how we compute the probability of multiple independent events occurring. We multiply their individual probabilities. For instance, if we toss a fair coin, the probability of getting heads is 1/2. If we toss 2 fair coins, the probability of getting heads both times is 1/2 times 1/2, or 1/4. If we toss 3 fair coins, the probability of getting 3 heads is 1/2 times 1/2 times 1/2, or 1/8. Now back to the problem. Remember, our claim is this: there's a 1% chance that no 2 people mark the same day on the calendar. Now, to find this probability that nobody has marked the same date as anyone before them, we simply multiply the probabilities of each person selecting a unique date. We can do this because each person's birthday is independent of the others, just how the results of coin tosses are independent from one another. Now, the first person marks the calendar, and since the calendar is empty, his odds of marking an unmarked date are 365 out of 365. Now, the second person marks her birthday, and since one date is already taken, her odds of marking an unmarked date are 364 out of 365. Now, the third person marks his birthday, and since 2 dates have been marked already, his odds of marking an unmarked date are 363 out of 365. You can see where this is going. Now remember, we're trying to compute the probability that after all these people mark dates, nobody has marked the same date. So in computing this probability, we get 365 out of 365 times 364 out of 365 times 363 out of 365, and so on, 57 times. The resulting expression looks like this. So let's simplify. Your calculator probably won't be able to compute this expression, so let me send you to a website that will, wolframalpha.com. By the way, this website is very helpful for your math homework. Take a look and see what it can do. I think you'll be impressed. So after you input this expression on Wolfram Alpha, you'll find that the result is 1%, or less than 1% in fact. This means that there's less than a 1% chance that no 2 people mark the same date on the calendar. That is, that no 2 people share a birthday. This shows that there's a 99% chance, in fact, a greater than 99% chance, that in a crowd of 57 people, 2 people share a birthday. Isn't that weird? So the next time you're in a group of 57 people, run an experiment. I bet you'll find that 2 people share a birthday. In fact, I'd be willing to wager $99 to your 1. For more bizarre math facts or for help studying, visit Wasatch Math Tutors on Facebook, Instagram, or YouTube. Thanks for watching.